Okay, ladies and gentlemen, we're going to look at multiplying polynomials through examples using algebra tiles. So algebra tiles are a physical tool that you can manipulate and move around. We have digital ones online that you can move around, so you can kind of picture what's happening with these multiplying of polynomials. One key thing that you need to know is that algebra tiles are like this. We've got a block, a line, and a big block. This little block just represents 1, not like 1 unit. It's just the number 1. So if you're adding 1 plus 2 plus 3 plus 4 plus 1 plus 2, you'd be adding blocks. The stick is x. Okay, we're not learning about the base 10 system. It's not 1 10/100. Sorry. And if this length is x, well, then that makes this length x and this length x, which makes this box represent x squared. X times x. The area of this box is x squared. Okay? So when we're talking about algebra tiles, that's what you need to remember. Good.
Let's go
Example
online
1, we're using algebra tiles to model the product of, first, 3x times 2x plus 1. So you have your grid drawn for you there. We need to put one of our polynomials in the vertical space and one in the horizontal space. It does not matter what you put where. I'll do the first one with you, and you're going to be expected to be able to draw the second one on your own. So, remember, x's are bars. So on the vertical, I'm going to do my 3 x's. I'm going to make sure they're generally the same size and shape. 3 x's. And down at the bottom, I have 2 x's plus 1. Well, let's look at what happens. Here I have x times x. Here I have x times x. Here I have x times x, x times x, x times x, x times x. So these are all x squareds. All these big boxes are x times x, which is x squared. Now what I have left is x times 1, which is 1x, so a bar. And then I have x times 1, which is 1x. And then I have x times 1. All of these are just x. So in orange, I have my product. I have 6x squared plus 3x. Go ahead and try your second one there. Use algebra tiles to model the product of x plus 2 times 2x plus 3. So choose one of your axes to be x plus 2 and the other one to be 2x plus 3.
Does it matter?
It does not matter, but you should be able to look at the one that's longer and do the statement that's going to be longer there. Finish out your multiplication and you can check the board to see if you got the right answer in a minute or two. Okay, go ahead and double check the board to see if you did it correctly and you got the correct final answer of 2x squared plus 7x plus 6. Now you know how to multiply polynomials using algebra tiles. We're going to quickly learn about the distributive property and then do a couple of examples using the distributive property. Okay, the distributive property is an algebra property. An algebra property used to multiply polynomials. It's an algebra property used to multiply polynomials. So we can take a first really easy example and just look at what happens when we have two polynomials. Let's say the monomial 2 times the binomial 3 plus 6. We're going to look at this in two different ways, just to show that the distributive property works and always works. We could solve this using BEDMAS. or we could solve it using the distributive property. Okay? If we use bedmass, we need to deal with what's inside the brackets first. So 2 times 3 plus 6 would end up being 2 times 9, which would equal 18. If we use the distributive property, which in this case is not easier, but it is when you're dealing with variables, means we're distributing the 2 to both terms inside the binomial. So 2 times 3 plus 6 means we're doing 2 times 3, which is 6, plus 2 times 6, which is 12, which equals 18. Did we get the same answer both ways?
Yes.
Yes, we did. Well, let's look at this in the case with variables. Let's look at 2 times 3x plus 6. So it's a similar problem, but this time we have an 3x instead of a 3 by itself. If we look inside this brackets, we need to deal with the brackets first, right? But 3x and 6 cannot be grouped. They are not like terms. They have different variables. 6 is just a constant. It's just a number value. This means that there are 3 x's. 3 x's. X plus x plus x. So what do we do here? We can use the distributive property, which means we're distributing that 2 to both terms inside the binomial. 2 times 3x is 6x. 2 times 6 is 12. According to the distributive property, this statement is equal to 6x plus 12. Okay?
You can't use bedmass? You can't even use bedmass for that?
We did technically use bedmass, but once you can't group anything more inside the brackets, then you go to multiplication. And we distribute it. Yep. Okay, let's do a more challenging example. Let's do 2 binomials. Yes. We've got 2 binomials. Let's say we've got x plus 2. We're going to multiply that by x plus 5. Now what this means is that we're taking both the terms in the first set of brackets, both the terms of the first factor, the first binomial, multiplying it by both of the terms of the second. So what that really means is we're going to have x times the second bracket, and we're going to have 2 times the second bracket. And now we can distribute the monomial to both terms inside the binomial. X times x is x squared. X times 5 is 5x. And the same thing on this second one. 2 times x is 2x. 2 times 5 is 10. And now we can group our like terms. We only have one x squared term. We have 2 x terms. 5 plus 2 is 7. And we have a constant of 10. Now who knows a faster way to get from here to here? I heard someone say it, is why I'm asking. FOIL.
Oh, first inside, outside, last.
First times first, outside times outside, inside times inside, last times last. So let's go ahead and look at, let's see what this looks like if we FOIL it. X squared times x plus 5. And we're going to FOIL it. So here we have first times first, that's x squared. Outside times outside, that's x times 5, which is 5x. Inside times inside, 2x. Last times last, 2 times 5 is 10. Group like terms, x squared plus 7x plus 10. So we get the same answer. FOILing is the application of the distributive property. Okay? And it works for monomials, binomials, trinomials. It works for all of them. Just if you're doing it with a trinomial, there's more terms to multiply by the other thing. So you're not actually FOILing. You're making sure that every single term in one bracket gets multiplied by every single term in the other set of brackets.
Wait, no, how'd you do it?
Okay, looking at example number 2, which is just using the distributive property. Here we go. We're going to find each binomial product. I'm going to leave A alone. You can do A by yourselves at some point. I'm going to do example 2B. In B, we're given the factors x minus 2 and x plus 4. And all I need to do is use my distributive property, which means I'm foiling that. So sometimes if I'm just getting used to doing it, I will write FOIL so that I make sure I account for all of the terms that I need. First times first means x times x, which is x squared. Outside times outside. And you can see by those arrows that this x has now been multiplied by both of the terms in the second bracket. So x times 4 is 4x. Now we have inside times inside. That's negative 2x. And last times last. Oh, I did it backwards. No. Oh.
No,
You did it right.
You did it right.
It's minus 8.
Outside times outside. Oh, I didn't here. This one and this one. Minus 8. Now we can group our like terms. There's only one x squared term. The x term has 4 minus 2. So that's 2x minus 8. In C, you're doing 3x plus 7 times x minus 5. And again, I'm going to write FOIL so that I get all of my terms and I make sure I do it properly. And you go ahead and do first times first. Then go ahead and do outside times outside. Inside times inside. And last times last. Group your like terms.
First times first, first times last, second times first.
And you're done.
Yes, it is.
You liar.
I see you.
Okay, let's head off to example 3. Same principles will apply. It just gets a little bit busier with one extra step. So go ahead and rewrite question A in a place where you can do some work on it. And now we see that we actually have 3 factors. We have negative 2 out front, and then we have our 2 factors, which are binomials, inside the brackets. So this is the product of 3 factors that we're going to be finding. And the key to remember here is first find the product of the binomials. So first we're going to FOIL these guys, and we're just going to leave our negative 2 out front and multiply it by the answer in our next step. Okay? So we need to have a little equal sign here beginning our next statement. We're going to leave negative 2 out there. We're not going to deal with it yet. And whatever happens is going to still get multiplied by negative 2. So you don't need to draw this last bracket. I'm just showing you that whatever we FOIL is going to be inside here. And once we simplify, it's still going to get multiplied by negative 2 at the end.
Now we're using BEDMAS.
We are always using BEDMAS. BEDMAS never goes away. Always.
That one won.
Yep. But we're also foiling. We're using our distributive property. So here we go with our 2 binomials. First times first. 4x times 7x. 28x squared. If you call out an answer, then don't call out an answer on the next one so that somebody new has to call out every single time. Outside times outside is 4x times negative 6. Negative 24x. Inside times inside, that's negative 5 times 7x. Negative 35x. And then last times last is negative 5 times negative 6. Positive 30. Good. Now there's 2 ways you can do this part. You can either multiply the negative 2 by every term inside the brackets and then group like terms, or you can group like terms right away. I see we have 2 terms named with an x variable, so I'm going to leave my negative 2 out here. Inside the bracket I reduce to 28x squared. Ooh, and then I have to group my x terms. Negative 24 minus 35 is negative 59x's. And plus 30. And my last step now, I'm still using my distributive property because this negative 2 has to get distributed to every term inside the brackets.
So you have to,
Negative 52.
so you have to square the 59, negative 59.
56.
You add it to
X squared. John.
They are
I know.
over here, like this answer.
Yeah.
It's not 59x squared because here I'm not multiplying the x's, they're attached by subtraction. Okay, so they're not, I'm just have, if x's were oranges, I'd have 24 oranges and 35 oranges. Right? So I don't end up with squared oranges. Oranges will still be round. Okay, here we go. Negative 2 times 28. Negative 56x squared. Negative 2 times negative 59x. Positive 118x. And negative 2 times 30 is minus 60 as our constant at the end. So 1 or 2 steps trickier, but not so bad after all. Let's do the last one, which is a multi-step one. I'm going to clear this. You double check that your b is the same as my b. I've got 2x plus 7 times x minus 3, and then minus 4x plus 3 times 2x minus 1. And right away you'll notice that this subtraction sign splits up the whole thing. So I'm not going to deal with these things together until the very end. Right now I'm going to deal with the product on the left, which has 3 factors, and then I'm going to deal with the product on the right, which has 2 factors. So here we go. Same steps as last time. I'm going to leave the 2 outside and deal with, I'm going to FOIL this. Okay, you go ahead and FOIL those binomials. And after you've simplified, probably will take you 2 steps, go ahead and just look at what you have and see if it's the same as what I have.
Isn't it 3x? Not 4x.
7x's minus 3x's is 4x.
Or 7 times 3.
7 times 3 is negative 21.
Yeah, so it's, oh.
Okay, do the same thing for the 2 binomials on the right side of the subtraction arrow here. So foiling them again.
No, this is 7 times x is 7x.
Yep.
Not 4x.
And negative 3 times x is negative 3x.
You see one.
So I skipped a step. This is the simplified answer. So this is what you should have in the next
Say
step.
never skip. What is this?
So here we got 8x squared, and it's in brackets.
Oh, I see what you did.
Oh, hee-ho.
You're smart.
This is going to be 6x minus 4x. See that? 2 steps in one. Outside and inside. 6x minus 4x is 2x. And last times last is negative 3.
Text me your homework today.
Excuse me. Now this 2 has to get distributed to everything inside the first brackets. Hopefully you're still staying ahead of me. I'd like you to stay ahead of me. Maybe I'll just pause for a second.
How did you get 2x minus 3?
Yeah, 3.
Did you get positive 6x and minus 4x
2.
inside your bracket?
5x.
Oh, then you added instead of multiplied.
Take away
Yep.
the 2.
Double check your next step and go ahead and check your answer. That is expanded and simplified. Way to go. Your homework is recorded for you at the bottom of the page. You have 4 minutes. You may ask, I would use that 4 minutes to ask questions.
I'm hungry.